This short video demonstrates the Technosylva Wildfire Analyst Enterprise product subscription service. In particular, we're going to focus on the real-time, on-demand fire spread prediction capabilities available through the FireSim app that uses cloud-based computing in client-side applications. The map you see on the screen represents a wildfire risk forecast generated with the Firecast application using the same Wildfire Analyst Enterprise product. This map represents the conditional risk, or in other words, the highest risk ignition sources for this specific time period. The timeline on the bottom demonstrates the 72-hour prediction provided across this time frame from October 13th to October 15th, 2008. The colored bars represent risk forecasts every 3 hours, and the color coding represents a percentile distribution of the worst risks to structures based on fire spread from millions of simulations conducted daily and hourly throughout this entire time period. This risk forecast demonstrates a Santa Ana condition that occurs at the end, the October 15th period of this forecast. Looking at 6 a.m. on the 15th, we can see considerable risk associated back with possible ignition locations across the area. Using this as reference, we're going to zoom into this area here, the Julian area, which often has high ignition risk. In other words, ignition starting from this area will spread and cause significant damage to structures. So let's zoom into that area and run some wildfire prediction simulations. We'll turn off the risk forecast and open up the wildfire prediction tool. As I zoom into Julian, we'll use the globe interface to look around the landscape. We can see a mountain ridge and town site where a significant amount of people live in a classic wildland urban interface area. Let's go ahead and run a 6-hour simulation. We'll start it on the worst day of the Santa Ana condition, the 9 a.m. on the October 15th. Identify a location somewhere on the landscape here and run the simulation. Of course, specific ignition points can be defined on the map using multiple points or lines, but they can also be defined by explicit lat-long coordinates and keyed into the interface under the ignition location. Multiple lat-long coordinates can be keyed in, or you can use an address search capability to search for a specific address. The combination of identifying an explicit ignition location and the pan and zoom capabilities of the map provide considerable flexibility in defining the actual ignition locations. In addition, default parameters are defined so that you can initiate the ignition and simulation very quickly. In this regard, I've got it set to a 6-hour default with certain criteria to define the extent of the simulation area and the level of urban encroachment using advanced urban encroachment algorithms that are built into the software. Typically, simulations take in the order of 30 to 60 seconds, depending on the specific weather conditions. Once we've submitted this simulation, a request is sent to the Wildfire Analyst Enterprise server. It compiles the necessary data, fuels, terrain, weather, live fuel moistures, and runs the simulation. As a result, once the result is finished, it is passed back, downloaded to the local device, and then is available on your computer for viewing. So the cloud-based computing is used to generate the ignition and the simulation, but the results are passed down so you can do everything locally on your device, and an ongoing, constant internet connection is not required. Once it's returned, as we've just seen, the user is now free to review and interrogate the simulation results. It's important to note that the spread simulation uses explicit hourly weather conditions that change throughout the duration of the simulation. It does not use constant weather. It is using a prediction system that has unique observation each hour. This capability is unique and different from most other government-based wildfire simulation capabilities. Let's review the outputs of this spread simulation. I'll zoom in with the map. we immediately get some feeling for that spread. And of course, the global environment allows us to look at this with different context and orientation as desired. I'll zoom a little back in here, and we can see hourly what that simulation is like. Given that these are Santa Ana conditions, extreme weather conditions, we see significant spread from the eastern area into western side of the county. This simulation was run for 6 hours. Let's look at the results. When the simulation is undertaken by the cloud server, it automatically calculates a variety of outputs. First and foremost, the size of the and the number of impacts. In this case, 938 buildings would be impacted over that time frame. In this case, 695 poles and a population of 181 people. We also calculate a likelihood of containment, which is a suppression difficulty rating based on the characteristics of the fire behavior and the spread potential. This allows the user to immediately see if this is a fire that would be easily contained or not if resources are available. Given the Santa Ana conditions and the very quick spread of this fire, the level of containment is very low. In other words, the likelihood that this could be suppressed easily and quickly in initial attack are very low. Let's go ahead and look at the detailed impact analysis table to see what kind of impacts this fire would have. This impact analysis is generated on the fly with every simulation and available to the user in a data table. As we can see, as I turned on the map, we can see the different information that's calculated for this simulation. Buildings are shown in green, and we see very quickly which buildings are impacted, as well as those on the periphery. I'll zoom out a little bit, given the real estate on the screen. I'm working off a small laptop here. And I can see a table that shows me all the buildings. It identifies the distance to the ignition source, the direction from the ignition source, most importantly, the time to impact. So in this regard, the first building is impacted in 1 hour and 12 minutes from the ignition time. And as I click on this, you can see those highlighted on the map in white. Clicking on that, you can get unique information about the impact and time of impact. In addition, the impact distance, time of impact is also calculated. So in this case, it would be 1 hour and 12 minutes since the ignition, and it'd be 1712 as the time the fire would hit this. The simulation also identifies which buildings are on the periphery. So if I zoom out, you can see that there's lots of adjacent buildings or structures on the periphery that weren't hit yet as of this simulation. As I slowly walk through the simulation, we can begin to see how buildings are impacted. In addition to the buildings that are impacted, we can also see where population lives. We can look at populated places, and we can also use a critical facilities, in this case, electric utilities for one of the premier investor-owned utilities. The simulations are done quickly and efficiently throughout that landscape, and of course can be submitted from mobile devices or from desktop. At any time, I can connect to the server and see what simulations exist out there, and in fact peruse those really quickly by simply hovering over them to get a quick feeling of what those simulations are like. The system accommodates millions of simultaneous simulations if desired. This little demonstration shows the real-time simulation capabilities of an on-demand system serviced by Wildfire Analyst Enterprise.